everyone, this is Vinay. Welcome to Learn Well with Vinay. In today's videos, I will start from absolute basic. I'll show you how to create a new account project, how to add a floor map and prepare an office area for predictive design. And by the end of this video, you will know how to add a floor map correctly, how to scale the map, basic setup needed before starting predictive design. So let's start. First of all, after opening the Ekahau, here you can see we have an option. Let's add a flow plan to the project. So click on here. So here I have this format. This is a JPG image file, but you can use PDF files and DWG files, AutoCAD files. Okay. So here the first and most important thing is scaling. So what you have to do is you have to check with your customer or the person who is on site what is the scale of any two known points and to set up a measurement from one point to another point. As you can see here, here we have our scale tool. So set the scale of the drawing indicates two known points on the map and then type in the real world. So on this map you can see we have already a scale which is 11 feet and 7 inches and 14 feet and 7 inches. So let's convert this in meters. Even we can use it in feet, but it's better to convert in meters and then set up our scale. So this area from this wall to this wall, so let's zoom in properly. After converting this 11 feet and 7 inches, this area is now 3.15. Okay, let's press enter. So we have set it up this scale. Now let's verify this one. Uh, it is approx 4 meters, right? So here our scale is perfect, and let's check one more time. So it is still showing 3.9, but we can consider. So let me type it 0.08. This is the exact number of this scale in meters. So let's recalculate this, and now you can see it is coming up 3.2. So in Ikaho, it will not show you like 3.15. You can type 3.15 meter, but it will not never show you 3.15. It will show you 3.1 and 3.234 like that. So our scale is done. Now after the scale, what is important thing? So first of all, we have to draw an area on which area we need wireless coverages and what are the exclusion zones. So let's set up the area. So this is the area from this angle to this, clicking, and then here we can double click, and now our area is this blue area is set it up. So the area is set it up. Now what I want, I need a coverage requirement. Coverage requirement means we'll go to the advanced. Here you can see how best practices we have a lot of. So what is basic connectivity? We'll go to this project coverage requirements. Let's see basic connectivity. This is the basic connectivity, but this is an office area. So here we are going to use the Cisco guideline design. So this is what channel interference we can use till 4. Okay, make it default and close this. So here now we are going to use design guidelines. We will use the Cisco APs. That's why we have choose. Even we it depends on the client what type of APs access points they need on this area. Now our scale is set it up and we have drawn the area. Now let's draw the exclusion zones. So exclusion areas where the signal and coverage is not required. So you can see here these are toilets. So in toilets they don't need wireless coverage. So later on we are not going to place any access. So now this is done. After this, what is next? So the next is we are going to draw the walls. So let's mark the wall. So to draw the walls, we will go to this view option, and from here we'll untick this area. So this area is not visible, and we'll untick this exclusion area. So this red strip lines are also, they are not visible, but they are on this map. Now let's draw. So here you can see we have wall, straight wall. So we have multiple types of wall, rectangular walls, predefined walls, but for now we are going to use straight wall. So this is our straight wall. Now first of all, you need to know the exact wall material type, which wall is what. So you can check with your on-site person or take help from the customer to get the wall material details. So here I know this is our concrete walls, all the blacks are our concrete, and inside walls are made with dry. Rest of the this stripped this black lines, these are our glass wall. Okay, and the doors, you can see the double doors are made with glass, the single doors are made with wooden, uh, which we will use drywall, and these blues are glass. So here we are going to use the glass wall. Let's make our wall first, and then we will proceed with the AP placement. I will choose first concrete wall concrete 12 dB. Here I am making this wall for now glass, but you will get to know later once this is done. Now we have selected all the glass walls, and we'll right click on this selection, and let's change this window thick 3 dB. All this glass now. Now let's make the inside wall. All the markings of concrete wall, glass wall, and dry wall are done. We have marked all the partitions on this map. So this is one floor layout. Now what we are going to do is we are going to count the users, how many users we have on floor area. Open this area, areas. Now let's count. So 1, 2, 8, 9, 13. So the 13 chairs are visible for now, but let's assume we have the conference room, guest will come, conference room, 13 plus 4, 17. Let's assume here we have 2, 2, 1, 17, and 22. In server room, maybe some vendors or engineers will come. So let's make it 25, and all over let's make it 35. We will take a rough estimate. So 35 users are there. Just to remember this, we'll add a map node. 35 users floor. So what does it mean? 35 users, but how many? One user have two or three devices. Let's say this user, right? You have a laptop, a mobile phone, or maybe an iPad. So let's count 35 into 3, and now we will set up our add devices. What he is going, a 60 smartphone, how many users? 35, 35 smartphone. I think we will use ISLA 4 MB. We'll add one laptop as well. Those 5 users, background saying very high SLA for this laptops, tablet. I don't see, but let's use this only. How many access point? The number of access point is required. How many number of? So for that, what we are going to do is we are going to use this smart feature AI auto planner. I'll let you know how to use this. So we'll click on this AI auto planner. Now we will go to this advanced. First of all, here we will 9164i. So this is Cisco Catalyst 9164i for this office area. We'll go to this advanced option. Before this, let me configure a profile. We'll go to this preferences. Instead of milliwatt, megawatt, we will use this dBm. Save it. Then we will go here. AI auto planner. Now all these power levels, the transmitting power are coming up 8 dBm, 14 dBm. This is auto. So we'll go to advanced. Let's configure this. 8 dBm is fine for this office, but we have concrete walls all over this offices. So we will going to use 11 dB power. For this 5 gigahertz, we are going to use 90. Same for 6 gigahertz, we are going to antenna height meter from the floor. So here we are going to mention the floor to ceiling, which is 3 meters. Now number of devices 155, it is already here. Requirement here, even we can configure this from here as well. This is fine. Now channels, we are going to use 40 megahertz on 5 gigahertz and 80 megahertz on for better channel planning. And on 2.4, we have to always use this three non-overlapping channels 1, 6 and 11. Regarding these channels, I'll let you know in next video what is the use of this channel, why we are using this channel, why we are using 40 meg, what is the, so we'll get to know all these. Let's create this. Now it is automatically simulating access point sharing. So now everything is prepared, but on my desktop there are a lot of things coming, use channels, Bluetooth. So what I'm going to do, I will go to this view, I will hide radios, I untick all these three. So now it's showing like, let's check the coverage on the server room. The signal strength is failing, it is minus 67, it is not, it is beyond our threshold, but minus 67 is fine, it is not that much bad, because until minus 75 the users can use the internet very well, pretty much well. And here you can see also the door is closed for now. What if the door is open? If the door is open, then you can see the coverage is pretty much, it's minus 60. But let's close this door and we will align all these APs to the required positions. So this is the electrical room. On this electrical room, mostly there is no much internet use. So what we are going to, we'll place this access point on this corridor. So on this corridor, here on this corridor, we are losing our signal. What we are going to do, so we will place our access, but if we will place our access, we don't have any coverage on this office room on 2.4. What about 5 as well and 6 as well? So now it's better to place our access point here only, so that we will get access on this electrical room, office, both the areas. How about this one? Why we are going to place this? Let's place this, and the coverage is same for this. We'll place this access point here, so that we can get coverage this area, this area, this area. This is for secondary. Let's delete this, move this little bit, covering a lot. AP is impacting most of this as well. So these four APs are important. We have to place all this exactly, and even we'll place this outside of things. So It's better to place this inside this. Can we move this little bit? Yes, we can. So this gray spot is gone. Before this, we have a gray spot. Now we have placed this. So gray spot. Now, what about this? Let's place this fine. What if I will place this inside this office? I don't see any gray spots here, and this AP inside this looks pretty good. Now, this is our design. So, are we able to remove any access? Let's check this AP. So, this conference point is, not we are going to do delete that. What we will this access. So, for this conference room, this, and this three access are giving pretty much good coverage. Till minus 60 dBm. Minus 60 dBm is very good coverage. The second 5 gigahertz band is. Now let's move to secondary. The secondary is failing in a few areas, but the secondary, it is failing in the corners. And here we have, let's add the second. So what I'm going, I can access. Maybe it will cover this and get this. This is good. This as well. Now in the corner of the areas only we have some secondary source, this electrical room, which will not impact the overall performance of this. So this is fine. Now it's client call. If they need Wi-Fi here, we will place one more access point and somewhere here so that we will get proper secondary strength. But this is also fine. It is. So this design looks good. We have used 7 access points for this 400-meter square. Why? Because partitions are made with concrete. If all these partitions are made with drywall, then probably we will need 2 access points for this line and one maybe 1 or 2 access points for this line and 2 access points. So all over 6 access points. 6 access points will cover all this, and might be if this as well drywall, then probably we will need 5 access points. Yeah, 5 to 6. But for now, 7 access points. Good. Let's do the channel plan because we have added some APs here and there. We have changed the position. We will go to select a network. Below of this 40. Good. Let's create. Now you can see here 2.456 everything is 100%. Secondary is good and interference. What about this throughput? The throughput rate is quite good here. What is the it is 290. 2.4 is. Let's check data rate. So data rate is also and inspect what is the pass rate is signal strength 9%. Secondary is also 90. Noise is 99. Everything is above 98. Yeah, 97. Because secondary in some corners is failing, but it will not impact the overall performance. So this predictive design is done. Now it's time to save the file. How to save it? So we have an option save. Save to our Ekahau cloud or save a local project. We have two options. We can save this project in our laptop or to our account. So both options are fine. I am going to save this file, a local project. Yeah, learn while. So let's make it ground floor. Yep. Now the name is. Now we can close this file and thank you. Thank you everyone.